video, we're going to be solving practical problems. In our previous video, I gave you the definition of Riemann Liouville fractional integral and the capital derivative. Today, we're going to use those definitions in solving practical problems. Here we have a question saying, find the fractional integral of order alpha, given to be half, of the function f of x is equal to x using the Riemann Liouville definition. Now, what we have here is the Riemann Liouville definition. So let us begin. So solution. Now all we need to do is just to substitute. We have our integral, because alpha is given to us to be half, so in place of alpha we're going to replace it with half. And from our question you can see our function given here is x. So in place of f of x we are going to replace it with x, because that is our function. Is equal to 1 all over gamma. This is a gamma sign, gamma of alpha, which is alpha is 1 all over 2, into the integral from 0 to x of x minus t in bracket. Then we have our alpha to be half. So when we say half minus 1, we have raised to power negative 1 all over 2 f of t dt. So that's what our integral is now. And in this case, we're going to try as much as possible to simplify this. Here we have the gamma function of half to be equal to the square root of pi. Now substituting this back into our equation, our integral, I meant to say we have our integral of half of x is equal to 1 all over the square root of pi into the integral from 0 to x of x minus t is to power negative 1 all over 2 t dt. So here there's going to be change of variable, because our integral here is a little bit complicated. So in order to simplify it, we're trying to, let's equate this. Let's say we say our t, let's make t to be equal to xu. And so if t is equal to xu, then the t will be equal to x du. Now what that means is that u is a fraction of x ranging from 0 to 1. That's as t moves from 0 to t. So our integral will now be transformed into this. So we're going to have our integral. We have integral of x, which is going to be 1 all over the square root of pi into the integral 0 to 1 of x. Now remember our t is equal to xu, so it will be minus xu, close the bracket, raised to power negative half. Then we have our t, which is xu, and then our dt. Our dt here is given to be x du. We are now going to factor out our x in this integral. So we have the integral of u, which is equal to, then our x, we're going to have x raised to power 3 all over 2 over the square root of pi, okay, into the integral from 0 to 1 of 1 minus u, close the bracket, raised to power negative 1 all over 2. Then u du. Now our integral is a beta function, which makes it easier to solve. This is obviously a beta function. So, and this is given to be the gamma of 3 all over gamma of 3 all over 5 all over 2, I beg your pardon. 5 all over 2. Now, simplifying this, if we try to simplify this now, we have that the gamma function of 3, gamma of 3 rather, is given to be 2. This is so because if we have the gamma function, the gamma function of n minus 1 factorial is given to be, if we have our n to be 3 minus 1 factorial, 3 minus 1 factorial, which will give us 2 factorial, which is still the same thing as 2. So I think you need to revisit the gamma function. And here we also have here the gamma of 5 all over 2. Gamma of 5 all over 2 here can be given to be 3 all over 2 into the gamma of 3 all over 2, which is now equal to 3 all over 2 multiplied by the square root of pi all over 2, which will eventually give us 3 the square root of pi all over 4, I meant to say. So trying to simplify this, if we try to simplify this, okay, we now have 2 all over what we have here to be 3 into the square root of pi over 4. Simplifying now, we have 8 all over 3 into the square root of pi. So now we can take this back into our integral, because this helped us to simplify the integral. The integral is a beta function, which makes it easier for us. So if we try to substitute it back, we have our integral to be equal to x raised to power 3 all over 2 all over the square root of pi multiplied by 8 all over 3 into the square root of pi. And this now simplifies to, we have 8x raised to power 3 all over 2 all over 3 pi, and that is the value of the integral. We have the derivative of the integral of f of x equal to x. Thank you very much.